clarify what this means. Like, oh, well, yeah, I get it now. We're going to have to see some examples of this. In order to do dimensional analysis, we need to know what these conversion factors are. Conversion factors are simply just ratios that are equal to 1. Ratios equivalent to 1. And then we're going to go through and list some here, because in order for us to be able to successfully use this dimensional analysis, we need to know how to apply the conversion factors. So, an example of a conversion factor. "12 inches to 1 foot." I'm going to go very basic today. 12 inches to 1 foot. 12 inches is equivalent to 1 foot. And anytime you have a fraction or a ratio where the numerator and denominator are equivalent to one another, then you're going to have a value of 1. So the value of this ratio is just 1. That's why it's a conversion factor. 1 minute, 60 seconds. There's another conversion factor, because a minute is equivalent to 60 seconds, so that would be equal to 1. Somebody give me a different one. Get the hang of what we're doing here. Leah? 4 quarts to a gallon. Yes. 4 quarts, 1 gallon. Yes. Sarah? 36 inches, 1 yard. All right. Let's go one more. Ellie? No. 3 yards, 9 feet. Good. We can continue this. We can go on and on and on. But the whole point of this is that all of these ratios are equivalent to 1. Because I got a little side lesson here for you. Tell me about, first of all, tell me what happens to a number when it's multiplied by 1. Just tell me. Stays the same? Nothing, right? Nothing happens to it when it gets multiplied by 1, and I need you to keep that in mind when we're doing this. The other thing I want to review with you is, how would you do this multiplication problem right here? How would you approach it? Jack? Straight across? Okay, so 4 times 1 is 4. Yeah, let's go that route, because that's what I wanted to talk about anyway. So what do you mean by that, Jack?
So both doors, they can be a 1.
Yeah, so they can't basically cancel each other out, right? Because then they become 1. 1 times 1 is just 1, and you get 5. All right, cross cancel. Let me show you another one. How about 3/4 times 2/3? Use that concept that Jack just reviewed with the cross-canceling, cross-reducing, whatever, to simplify. Simplest form. Julian? What is it? Uh-huh. So 1/2 would be your fraction? Mm-hmm. Now, when I look at this, I get rid of the 3's right away. Come on, right? So now you have a 2/4, and you might think, well, 2 goes into 2, and 2 goes into 4 twice. There's your 1/2. But that whole concept of cross-reducing is going to be important when we do this dimensional analysis. And I'm going to try really hard today to show you how this actually works. I think most of you are probably going to think, why are you doing it that way? I've got a way that works. It's quicker, and I'm getting them right. Why am I going to do it your way? And that's a fair question. You don't have to do it my way. You don't have to think of it the way that I am. Just keep in mind, these are going to get a little bit more challenging every time we do these. So if you're not fully comfortable with the method you're applying, maybe you want to look at my method here. I'll show you what I mean by that in a minute. Here's what I need you to do. Go to example 1. These three conversions, 84 inches to feet, 4 hours to minutes, and 1,280 centimeters to meters. Just quickly go through and make those conversions for me. Did you have them? you might find yourself going back to that bell ringer scenario where you're thinking, okay, do I multiply, do I divide? And if you remember that rule we talked about, then apply it. Make sure you guys agree with others around you here. So 84 inches. What's our value? How many feet are we talking? Mikey? 7 feet. How did you get 7, Mikey? So think back to our rule that we talked about earlier. We said when you're given the smaller of the two units, inches are smaller than feet, then you're going to divide by the conversion. This would be the conversion factor, and the conversion factor is 12 inches. So he applied that rule here, and it seemed to work out because I saw 7 when I was walking around from everyone. It's good. I'm going to come back to that in a minute, but let's go to B, 4 hours. What's our minute amount? Amelia? 240 minutes. Okay, and what did you do to get that? Mm-hmm. Okay. The rule, if you're given the larger amount, to get the smaller amount, you would multiply by that conversion factor. And how about this 1,280 centimeters to meters? We got our metric system represented here. Sarah? What do you think, guys? 128? 12.8? We like that better? Okay. So what'd you do to get that, Sarah? 100 centimeters in a meter, right? You're given the smaller units. You want the larger units, you would divide in that case. Okay. Now let me show you what dimensional analysis would look like and how we would apply this conversion factor to do this. And again, keep in mind, you might think, why are you doing it this way? You're complicating a matter that seems pretty simple on the surface. Why are you doing it this way? Just try to keep an open mind. And I would like you to write this down for the couple that I do so that you refer back to it. Because I think, I might be wrong, I've been wrong before on this, but I think eventually most of you are going to come around and want to do it this way as they get a little bit more challenging. Not everybody, but over experience shows me that after a while, our method isn't always like airtight. There's mistakes that are happening, right? It's not foolproof. So I would say anytime you're given an amount, like 84 inches, okay, I'm going to write that as a fraction. And I'm going to write it as 84 inches to 1. Very basic so far. And you already told me before that anytime you multiply anything by 1, it doesn't change it. It gets itself, right? Well, I'm going to multiply this by 1. But I'm going to multiply it by a conversion factor because these are all equal to 1. But I'm going to pick the conversion factor that's going to make the appropriate conversion. It's not going to make much sense for me to do like a minutes to seconds conversion here. All right, so I want to convert inches to feet. And I know that there are 12 inches in 1 foot. But I have to strategically write this. And this is where the people that aren't sure, they're like, well, do you multiply or do you divide? I can't really ever tell. Well, this will help you. Just like the up above, did I erase? Oh, yeah. Just like up above, how these numbers canceled out, cross-canceled, cross-reduced, units will do the same thing. So here I have 84 inches to 1 whatever, and now I want to multiply this by inches to feet. Well, I'm going to put my conversion factor like this. 1 foot to 12 inches. And by doing so, these inches here would cross out these inches here. You could also reduce the 84 and the 12 right now if you'd like, but it doesn't really matter because these other terms are just 1. So when you multiply straight across, you're left with 84 feet, and you're left with 12 because the units canceled out. So it's 84 feet to 12, and you would divide 84 by 12 to get 7 feet. But that just shows you how the units just get crossed out, get canceled. And you're not left wondering, do I multiply, do I divide? Well, you ended up dividing here. Okay? Yes, Ellie? That's a good question. So if I had this as 84 inches over 1, and I put 12 inches to 1 foot, do we see an issue with writing it that way? What's going to happen? Or what won't happen, maybe. It's probably a better way to say it. Finn?
Like not going to be able to. It's just going to be inches.
Yeah, like inches squared, right? Yeah, the units aren't going to cancel out when you write it this way. So you have to pick which way you write this conversion factor. I could flip them, reciprocate them, and it doesn't change its value. It's still 1, but you have to pick a way in which it's going to cancel them out. And the only way that it would cancel would be to do that right there. All right, let me try this next one, the hours. So 4 hours to 1. I want to convert this into minutes. So my minutes to hours conversion is 60 minutes in an hour. I have hours here. I want to be able to cancel out hours. So I would have to have my hours in the denominator so that they cancel. Up top, I have my 60 minutes. Now I do 4 times 60. I'm left with minutes. 1 times 1 is 1. You would get 240 that way. All right, why don't you give this next one a shot? We're converting 100 miles per hour, and we want to know how many miles per minute that is. Do it whichever way you feel comfortable. So today our focus is on, in a problem like this, it's converting one of the 2 units. So right now we have miles and we have hours being compared. Well, we're going to keep the miles the same, but the difference here is that we need to make a conversion from hours to minutes. So that's the conversion factor you need to focus on. So somebody tell me. I walked around, I saw some answers. I saw some correct, some incorrect. So anybody want to help us out in terms of how you would get this problem, how you would get this value, rather? Hayden, you want to talk us through it?
So what I did is I first wrote down 258, that's miles plus 60 miles per hour. And I
times 60, you said?
Yeah.
Okay. You want to divide? It happens. Well, and I told you before about that. It's a common mistake. So you divide now, okay? And what do you get? Yeah, 1.6 repeating. And what would that be? What would the units be? Miles per minute? How many did it just like that? 100 divided by 60. Okay. When I ask kids sometimes, I'm like, well, why does that work? Like, why does it all of a sudden just convert it into miles per minute just because you divide it by 60? A lot of times we kind of fall short on getting an answer to that. It's like, well, I don't really know why it does, but it does, right? But if you were to do it the other way, and I feel like a salesman right now trying to promote my method, but I'm just trying to get you to understand this. If I wrote this like this, guys, 100 miles per hour, 100 miles over 1 hour, that's another way to write it. And I want to get rid of the hours and replace it with minutes. My conversion factor needs to get rid of hours, replace with minutes. So my conversion is 60 minutes in 1 hour. But how would I put this ratio on my second ratio? Like, how would I put it? Would I do option A? Would I do 60 minutes? Oops, 60 minutes over 1 hour? Or would I do 1 hour over 60 minutes here? Option B. Which one would you advise us to use? Leah? Why? Good. Now the hours are gone. Now we have miles over minutes, so it's 100 miles in 60 minutes. Divide them out, you're going to get 1.6 repeating miles per 1 minute. That's just a unit rate, which we've been doing now for a few days. Okay? So that's the dimensional analysis way right there, if you're considering that. Let me tell you about this answer that I don't like. I'll show you some versions of the repeating decimal that I don't like. Don't tell me that this is just 1.6 miles per minute. Not the same thing. If you're going to round it, which it looks like you've rounded it to the tens place, then it's not going to round to that. You would call that 1.7 miles per minute. Or I would prefer, like we did with the repeating decimal, like that. Some of you might want to round to the hundredths. You could do it like that, but this one I don't like. Okay? All right, turn it over. You don't have that paper on there. You have these. So let's just try to knock these. We're going to do 3 and 4, and then we're going to stop for today. So go ahead and try 3, where you're converting this drink manufacturer. And try 4 also. So try to get both of them. Compare your answers to your partners. Okay, does anybody want to talk us through example 3? Teach us how you came up with this value. Amelia, go ahead. What do you got? 24 pints, 1 hour. So let me see. So you got 24 pints per hour, okay? So this what we need is a pints to quart conversion. What's their conversion factor there? Think about, ignore this problem. I'm talking about from your table, like how many pints are equivalent to a 2? So 2 pints is equal to 1 quart. So if we want to cancel out pints and replace it with quarts, what we want to do is we want to have our pints in the denominator. Okay? So we're going to use this conversion factor. So the 2 pints would go here, the 1 quart would go here, because these two should be equal to one another. That way, your pints cancel out. And keep going. What would you end up getting then? Yeah. Yeah, 24 quarts over 2 hours still, right? We still have that hours there, which means that's 12 quarts per 1 hour. That's using the dimensional analysis way, which I know not all of you did. In fact, probably only a few of you did that. So how many of you just took 24 pints and divided it by 2? Okay, and that's what we're doing here. We're doing the same thing here. But this just provides a little reasoning behind why all of a sudden did it turn into the correct answer. Why all of a sudden did that turn into quarts per hour? Well, we can see because we're crossing off units. So on this example with the football player, he's running 40 yards, and it takes him 4.5 seconds. All right, we want to keep the seconds the way it is. We're not converting the time, we're converting the distance. So we want to convert into feet per second. Tell me how you did it. Finn, how'd you do it? Okay. Mm-hmm. 26, it's not exactly 26 though, is it? It's 26 and 2/3. I'll just put FPS, feet per second. How many of you took 40 times 3 and then divided it by the 4.5? Okay, do we do it a different way then? Because this is right. This person is running 26 and 2/3 feet every second, which is really fast, by the way. So dimensional analysis, now I intentionally left what Finn gave us sort of skeletal here. I left it open because here's what I'm going to do. I'm going to add to what he had. He did 40 yards to 4.5 seconds. The conversion factor is that there are 3 feet in 1 yard. That's the only difference I would have said put in there, because yards get canceled. I still would end up with exactly what he has right here, and then I would ultimately end up with exactly what he has right there. So you guys are using this dimensional analysis. Maybe it doesn't set up the same way as mine, but that's okay. I would never tell you have to do it this exact way. Yes, Ellie? The units get canceled. Just the units on this one, not the 1 or the 40, just the units. That's all we're worried about right now. Okay? So tonight, be open to giving that a shot. Maybe it'll work for you, maybe it won't. It's up to you. But as we get a little bit more challenging questions here, we might consider going